There is a handful of sand somewhere near you right now. On a beach, in a bag of concrete, packed under a road. It is the most ordinary substance on earth. It runs through your fingers and vanishes. It gets in your shoes, and you curse it. It is so common that we use it as the very definition of worthless multitude, the thing there is too much of to count. Nobody has ever looked at a handful of sand and felt awe. And yet inside that sand is a material you are almost certainly looking through at this very moment. A material that let human beings see the cells in their own blood and the galaxies at the edge of the observable universe. A material that carries nearly all of the world's information as pulses of light through threads thinner than a hair. A material that is, right now, a few inches from your eyes, in the form of a screen, a lens, or a window. The strange thing is not that we have glass. The strange thing is that we ever got it at all. Because to turn sand into glass, you need a fire so hot that no ancient civilization on Earth could produce it. The temperature required to melt sand is higher than the temperature that melts iron, higher than the inside of a bronze furnace, higher than anything a Bronze Age human had any way of reaching. So the real question is not simply how we discovered glass. The deeper question, the one that changes how you see every window and lens and screen you have ever looked through, is this. How did people with no chemistry, no thermometers, and a fire that was physically incapable of melting sand still manage to pull a clear, hard, liquid then solid material out of the ground, thousands of years before anyone understood what they were doing? The answer is one of the most quietly astonishing accidents in human history. And like so many of these stories, it does not begin in a workshop. It begins with lightning. To understand how radical glass really is, you have to understand what it actually is. Because glass is genuinely strange. Most solid materials are crystals: salt, quartz, metal, ice. In a crystal, the atoms are arranged in a strict repeating grid, locked into position like bricks in a wall. That orderly structure is what makes most solids what they are. Glass is not like that. Glass is a solid in which the atoms are frozen in the chaotic, jumbled arrangement of a liquid. When you cool most liquids, they reach a temperature where the atoms suddenly snap into an orderly crystal and become solid. But if you cool molten silica fast enough, the atoms never get the chance to organize. They seize up mid-motion, locked into disorder. The result is a material that is technically closer to a frozen liquid than a normal solid. It is rigid enough to hold a shape for thousands of years, yet its internal structure is a permanent snapshot of chaos. This is why glass is transparent. In most solids, the ordered rows of atoms and the boundaries between crystal grains scatter light, bouncing it in every direction, which is why a rock or a metal is opaque. But the disordered, uniform structure of glass has nothing inside it to scatter visible light. The light passes straight through, as if the material were barely there at all. Transparency is not a lucky coating on glass. It is a direct consequence of that frozen liquid disorder. Nature makes this material on its own, but only under conditions of extraordinary violence. And ancient people who found it knew immediately that they were holding something that did not belong to the ordinary world. When lightning strikes sand, it can carry a temperature many times hotter than the surface of the sun, delivered in a fraction of a second. Where the bolt plunges into the ground, it fuses the sand around its path into a hollow, glassy tube. These tubes are called fulgurites. They are rough and brown on the outside, but the inner surface, where the sand actually melted, is smooth and glassy. A fulgurite is a fossil of a lightning strike, a physical cast of the exact path the electricity took underground. To an ancient person, this was a stone made by the sky god's spear, glass produced in the instant a bolt touched the earth. Volcanoes make glass too. When lava that is rich in silica erupts and cools too quickly to form crystals, it hardens into obsidian, natural volcanic glass. Obsidian is jet black, sometimes with a smoky translucence at the edges, and it fractures with a razor sharpness that no stone can match. Human beings noticed this a very long time ago. For hundreds of thousands of years, long before anyone dreamed of making glass, our ancestors were chipping obsidian into the sharpest blades on Earth. In fact, obsidian can be flaked to an edge finer than surgical steel. Stone Age humans were already using glass. They just could not make it. They could only find what the volcanoes had already made. And then there is the rarest natural glass of all, the kind that falls from beyond the world. When a large meteorite or comet slams into the Earth, the heat and pressure of the impact can melt the ground into glass and fling it across the landscape. In the sand sea of the western Egyptian desert lies a scattering of pale yellow-green glass, nearly pure silica, formed roughly 28 million years ago by some catastrophic event from the sky. It is called Libyan desert glass. And here is the detail that should stop you. When archaeologists opened the tomb of the pharaoh Tutankhamun, and examined the magnificent pectoral ornament laid across his chest. They found at its center a carved scarab of a warm, translucent yellow-green stone. For years, it was assumed to be some form of common mineral. Later analysis revealed the truth. The centerpiece of the pharaoh's jewel was carved from a piece of glass that had been forged in the sky, in a fireball, in the deep desert, tens of millions of years before Egypt existed. The king of Egypt was buried wearing glass that fell from the heavens. So before any human being ever made glass, glass was already known. It was found in the desert, chipped from volcanoes, dug out of lightning scars. It was rare, it was sacred, and it was understood as something the gods or the sky had made. Manufactured glass, the glass that would eventually let us see atoms and stars, required something else entirely. It required a fire that, by every rule the ancient world knew, could not exist. Here's the thermodynamic wall that should have stopped glass from ever being invented. Pure silica, ordinary sand, does not soften until you heat it to around 1,700 degrees Celsius. That is not a modest number. It is hotter than the melting point of iron, which is 1,538 degrees. It is hundreds of degrees beyond what a copper or bronze furnace could reach. The most advanced kilns of the early Bronze Age, the pottery furnaces that fired ceramics and smelted copper, topped out somewhere between 1,000 and 1,150 degrees. To melt sand, they would have needed to nearly double the effective reach of their fire. By every logic available to an ancient metalworker, sand was simply not meltable. You could throw it in the hottest fire you had ever built, wait all day, and it would sit there as sand. Not softened, not glowing liquid, just hot grains. The idea that this stuff could become a flowing, honey-like liquid that hardened into something clear and hard would have seemed like nonsense. The fire to prove it did not exist. And yet glass got made anyway, thousands of years before anyone could build a furnace hot enough to melt pure sand. The reason is a piece of chemistry so counterintuitive that it took modern science to explain it, even though ancient people had been exploiting it, blindly, for millennia. The trick is this. If you mix the right second ingredient into sand, the temperature at which it melts collapses. That second ingredient is called a flux, and the flux the ancient world used was soda, sodium carbonate. When soda is present, it breaks up the powerful bonds in the silica and drops the melting point from 1,700 degrees all the way down to around 1,000. Suddenly, sand becomes meltable in a furnace that already existed. The impossible temperature is not reached. It is dodged chemically by changing the material itself. But where would an ancient person get soda? In one specific corner of the world, they were practically standing on it. In Egypt, in a desert valley called Wadi el-Natron, a natural mineral called natron dries out of seasonal lakes as a white, salty crust. Natron is rich in sodium carbonate. The Egyptians already gathered it in enormous quantities because it was their primary substance for drying out bodies during mummification and for cleaning. It was one of the most heavily handled minerals in Egyptian life. Natron, sand, and a hot fire were all sitting in the same civilization at the same time. All that was missing was the accident that brought them together. There is one more piece, and its absence is a story in itself. Glass made from just sand and soda has a hidden flaw. It slowly dissolves in water. It is chemically unstable, a glass that weeps in clouds and eventually falls apart. To make glass that lasts, you need a third ingredient, lime, calcium from crushed shells or limestone, which locks the structure and makes it durable. The earliest glassmakers had no idea lime was doing this, but the sand they scooped up from beaches and riverbanks was often naturally full of crushed shell and limestone fragments. The stabilizer was already mixed into their raw material by accident. They were making durable glass for centuries before anyone knew that a third ingredient even existed, because nature had already blended it in for them. So the whole recipe, sand for the silica, natron for the flux, shell-rich sand for the stabilizer, was lying scattered across the ancient Near East, waiting for a fire and an accident. The question is, what lit the fuse? The oldest and most famous origin story comes from the Roman writer Pliny the Elder, who set it down in his great encyclopedia of the natural world in the 1st century. Pliny tells of Phoenician merchants, traders in natron, who beached their ship on the sandy shore of a river and stopped to cook a meal. Finding no stones to rest their pots on, they took lumps of natron from their cargo and used those instead, setting the cooking pots on blocks of soda directly on the sand. As the fire blazed beneath, Pliny writes, the natron fused with the sand and there flowed out strange, translucent streams of a new liquid. And this, he says, was the origin of glass. It is a wonderful story, and it is almost certainly not true, at least not exactly. A cooking fire on a beach cannot reach anywhere near the temperature needed, even with a flux. Modern experts regard it as a legend, a just-so tale invented long after the fact. But the legend is pointing at something real. It captures the essential truth of how glass was almost certainly discovered, not by design, not by a genius who set out to invent a transparent material, but by the accidental collision of the exact right substances in the presence of fire, noticed by someone paying attention to a strange residue that should not have been there. The likeliest real origin is quieter and even more revealing. Long before anyone made a lump of solid glass, ancient craftsmen were making something called faience and glaze. Potters and bead makers in Egypt and Mesopotamia, more than 5,000 years ago, discovered that if you coated an object in a paste of crushed quartz and natron and certain minerals and then fired it, the surface would fuse into a brilliant, glossy colored skin. That skin, the shimmering blue-green glaze on an Egyptian amulet, was glass. A thin film of true glass formed on the surface of the object in the kiln. For centuries, humans were making glass without knowing it, as a coating, a decoration, a byproduct on the surface of pottery and beads. And somewhere along that road, a craftsman fired a batch hot enough, with enough flux, that the glaze did not just coat the surface. It ran. It pooled. It gathered at the bottom of the kiln as a small blob of solid, colored material that was glassy all the way through, not just on the skin. Someone picked up that blob, held it to the light, and realized they were looking at a substance that had no business existing, sand that had become stone that you could see into. What strikes you about the earliest glassmakers is how much they achieved while understanding none of it. They did not know about silica, or sodium, or calcium. They did not know why one sand worked and another did not, only that the sand from a particular riverbank made good glass, and the sand from elsewhere made a cloudy mess. They did not know they were adding a flux. They knew that this white desert salt, thrown into the mix, made the difference between failure and a glowing pool of liquid. They read the whole process through color, texture, and the behavior of the melt, and they wrote none of it down as chemistry, because chemistry did not exist. They passed it hand to hand, master to apprentice, as guarded craft. The first objects they made were not windows, and certainly not lenses. They were beads and small amulets, precious things. For a long time, glass was not valued, because you could see through it. In fact, the earliest glass was deliberately made opaque and richly colored, prized precisely because it imitated rare gemstones. A bead of deep blue glass could stand in for lapis lazuli, the costly stone hauled across thousands of miles from the mountains of Afghanistan. Turquoise, carnelian, emerald, all of them could be conjured out of sand and fire by a skilled hand. Glass was, in its first life, artificial jewelry, a way of manufacturing the look of the rarest stones on earth. It was worth a fortune, and it was controlled by kings. By around 1,500 years before the Common Era, Egyptian and Mesopotamian craftsmen had learned to make hollow glass vessels, small jars and bottles for precious oils and perfumes, using a technique called core forming. They would build a core of clay and dung on the end of a metal rod, dip it or wind molten glass around it, shape and decorate the surface with threads of contrasting color combed into patterns, and then, once cooled, dig out the core to leave a hollow container. These little vessels were luxury goods, buried with the wealthy, exchanged between royal courts. Glass was still rare, still expensive, still the possession of the powerful. It would stay that way for over 1,000 years, until a single invention broke it open and put glass into the hands of ordinary people. That invention was the blowpipe. Somewhere in the Syrian and Palestinian region, around the middle of the 1st century before the Common Era, a craftsman made a discovery that changed glass forever. He took a long, hollow iron tube, gathered a blob of molten glass on the end of it, and blew. The glass inflated like a bubble, a soft, glowing balloon that could be shaped, swung, stretched, and formed into a vessel in seconds. Glassblowing had been born. It is hard to overstate what this did. Before glassblowing, making a single glass vessel was slow, difficult work, and every piece was a treasure. After glassblowing, a skilled team could produce cups, bottles, and jars faster than almost any other container in the ancient world. The cost of glass collapsed, and this happened at the exact moment the Roman Empire was rising to knit the Mediterranean into a single vast market. The Romans seized on blown glass and industrialized it. Within a century, glass drinking cups became so cheap and common across the Roman world that ordinary people used them daily and threw the broken pieces away. Glass windows, cast and later blown into flat panes, began appearing in Roman bathhouses and villas, letting in light while keeping out the weather, a small miracle we now completely take for granted. Glass had made the same journey iron once made. It began as a substance rarer than gemstones, buried with pharaohs, and it ended, through one accidental technique and one moment of mass production, as a material a common laborer could drink from. The democratization of glass, like the democratization of iron, quietly reshaped daily life for millions of people who never knew they were living through a revolution. And as with iron, the people who mastered glass were regarded with something close to suspicion and awe. A glassmaker took the most worthless material imaginable, sand, and by feeding it to a fire and breathing into it, produced a clear vessel that seemed to be made of solid, frozen water. To anyone who could not see the chemistry, and no one could, this was very near to magic. Later, in medieval Venice, the glassmakers of the island of Murano would become so valuable that the Venetian state moved them all onto the island, partly to guard their secrets, and the penalties for a master glassblower who tried to leave and sell his knowledge to a foreign rival were severe enough to include the threat of death. The recipes for the finest glass were guild secrets, hoarded like treasure, passed down in families and hidden from the world. The knowledge of how to turn sand into clarity was, for centuries, one of the most valuable secrets a human being could possess. Glass did not develop along a single line. Different civilizations pushed it in different directions, and some barely pursued it at all. In China, a civilization that led the world in so many technologies, glass remained a relative curiosity for a very long time. Chinese craftsmen poured their genius into ceramics, into porcelain and jade, materials the culture prized far above transparent glass. It is a reminder that no technology is inevitable. A society develops the materials it decides to care about. The Islamic world, by contrast, inherited the Roman and Persian traditions and carried glassmaking to spectacular heights, producing lustrous, enameled, and gilded glass that was traded across continents. Venetian glassmakers eventually cracked the secret of cristallo, a glass so pure and colorless it rivaled rock crystal, achieved partly by adding manganese, a decolorizer that ancient glassmakers had already stumbled onto and called, in effect, glassmaker's soap, because it cleared the sickly green tint out of the melt. That green tint, by the way, is another accidental fingerprint. Ordinary early glass is green, and the reason is iron. The same iron impurities that lurk in most sand tint the glass green, which is why you can still see it in the edge of a thick pane of cheap window glass. The whole long history of glassmaking is, in one sense, a war against the impurities that nature blended into the sand, a slow, patient campaign, waged with no theory, to make the material clearer and clearer until you could forget it was there at all. And that, in the end, is where glass did something iron never could. Iron built the physical world, the beams and rails and ships, but glass built our ability to see, and in doing so, it built modern science itself. Because once glass could be made pure and colorless and shaped into precise curves, it could be made into lenses. And a lens is not just an object. A lens is a new sense. Around the turn of the 17th century, craftsmen grinding curved pieces of clear glass discovered that the right shapes could bend light in controlled ways, magnifying the small and drawing in the distant. Put two lenses in a tube pointed at the sky, and you have a telescope, and suddenly a man in Italy is looking at the moons of Jupiter and the craters of the moon, and the universe is 1,000 times larger than anyone believed. Put a lens over a droplet of pond water, and you have a microscope, and suddenly a Dutch cloth merchant is looking at a teeming world of tiny living creatures that no human eye had ever seen, and the foundations of biology and medicine are laid. Think about what that means. Almost everything we know about the very large and the very small, the structure of the cosmos and the structure of the cell, the existence of germs, the map of the galaxies, came to us through a curved piece of purified sand. Glass did not just let us see through a window. It let us see the parts of reality that our own eyes were built too weak to reach. The material born as fake jewelry became the instrument through which we discovered nearly everything. And glass never stopped. The lenses in your camera and your eyeglasses are the direct descendants of those first ground crystals. The screen you may be reading this on is a sheet of specially engineered glass, chemically strengthened to survive in your pocket. And the message that carried this very video to you almost certainly traveled part of its journey as a pulse of light racing through an optical fiber, a strand of ultra-pure glass so clear that light can travel through miles of it and still come out the other side. The entire internet, the nervous system of modern civilization, runs largely on threads of the same material a Bronze Age craftsman once fished, baffled, out of the bottom of a kiln. So look around you right now, the window letting in the daylight, the lens of the phone or the glasses through which you are reading these words, the screen itself, the bottle on the table, the mirror on the wall, the bulb overhead. Look through any of it, and you are looking through molten sand, cooled so fast its atoms froze in the chaos of a liquid, made clear by a fight against impurities that took thousands of years to win. Every bit of it began as the most worthless thing on earth, the sand we invented as our word for worthlessness. Every bit of it required a fire that ancient people could not build, unlocked by a white desert salt they were using to preserve their dead, stabilized by crushed shells they never knew were there, and discovered, most likely, by someone who fired a batch of glaze a little too hot and found a strange clear residue pooled at the bottom of the kiln. They had no idea what they had found. They could not have known that the accident in that kiln would one day let their distant descendants look into a single cell and out to the edge of time. They only knew that the fire had done something it should not have been able to do, and that the sand, impossibly, had come out the other side as something you could see straight through. If this journey from lightning-struck sand to the lens of a telescope has captured your imagination, take a second to like this video and subscribe to the channel. It genuinely helps us keep digging into stories like this one, the hidden history buried inside the most ordinary things around you. Because here is the thought to leave you with. We tend to assume that the great materials have all been found, that the age of discovering something world-changing in a common substance is behind us. But every civilization before ours assumed exactly the same thing, right up until someone looked at the dirt beneath their feet and saw a skyscraper, or looked at a handful of sand and saw the stars. The next material that will remake the world may already be sitting somewhere close to you right now, as overlooked and worthless seeming as sand once was, waiting for its accident, waiting for someone to be paying attention. Thank you for watching and subscribe for weekly history lessons.